Alrighty, we're going to jump into 21. If you need anything before that, that's a different video. So on this one, it says draw a line FG. So let's go ahead and follow directions. I'm just going to make it a segment. So FG, and then we have a point H that's not on the line. So let's throw that point H right there. And then when you reflect it, remember that reflection, you're going to have the same distance here as you're going to have to the reflection point over here. So we know that that's the same distance. But what is also going to be congruent is the distance from H to F and from F to H prime. So that those are going to be the same. And then from H to G and H to G, sorry, to H prime to G prime. G, excuse me. There we go. We'll give this 3 tick marks. And I really should just make this 1, but we'll go to 4 since I used 2 in the middle. So which one of those is going to be the same? So obviously that's going to give us D. So ladies and gentlemen, boys and girls, let's move to 22. Now when you have a bunch of these different points, the answer has to be there. So just pick one. So let's just pick A. So it's reflected over the line y equals x. Alrighty. So that line y equals x is that right there. So when you flip it over, so 5, -2, so 5, -2 would be right here. We're going to move it. It's going to be some point up in this region over here. So that exact rule is you're going to go ahead and take your y and your x, and you're just going to flip their positions. So if this is 5, -2, then it's going to become -2, 5. So pretty close. So let's see which one of those. So 5, -2. So I have this one here and this one here, meaning C and A are out. So then look at which is the next point that they have different. So thankfully that's just B. So let's go ahead and take a look at B. So that's going to be -3, -4. And then when we apply that same shift, it's going to go and become -4, -3. And so that means our answer has to be D for 22. Alrighty, moving right along here, my friends. When you do these transformation problems, feel free to just make pictures and guesstimate as best as you can. I say guesstimate as we're about to do a problem where you really can't guesstimate, but that's usually a good way to start. All right. So it says take this line y equals -5. So y equals -x plus 5, excuse me. So there's plus 5, and then it's going to go down like this. So there's that line. So we are going to move it with this transformation. Okay. So I'm going to take this point right here, and I'm going to move it left 2, which is essentially saying x minus 2, and then down 3, which is y minus 3. So left 2, down 1, 2, 3. So if we take a look at this and then we say, alrighty, this is my point. Now let's go ahead and do that same slope, which is down 1 over 1, down 1 over 1, down 1 over 1. And we're going to notice that it goes right through the origin 0, 0. And we should have the same slope because this is a rigid transformation, which means every one of these points is going to be the same transformation, regardless of the colored points that I used here. So I could say, all right, the slope is still going to be -1. It's going to go through my b of 0. So that's y equals -x. That's easy peasy lemon squeezy. All righty. What is the distance between any point and then that transformation? So I'm going to pick the easiest point I can think of, which is 0, 0. Boom shakalaka. Then I'm going to move this transformation, which is over 4.2, down 5.9. So 1, 2, 3, 4, 5, almost 6 here. So that's -4.2, comma -5.9. And because, again, it's a rigid transformation, that any point that I apply this transformation to, it's going to be the same distance here. So that's why I use 0, 0, because it's easy. So x1, y1, x2, y2. We're doing distance. So 0 minus 4, excuse me, a -4.2 squared plus 0 minus a negative 5.9 squared. So a couple of things at this point. Time to just throw it in the calculator because it says round your answer to the nearest tenth anyways. So throw it in the calculator. Don't even worry about the algebra. But when you're all said and done, you get 7.24. Alrighty. 25. So this is a little bit different. This is our vector notation for coordinate notation. So with this vector, ladies and gentlemen, boys and girls, what I would do is I would change this to x plus 2, y minus 5, because that's the coordinate notation that we're a little used to seeing. So it says, which of these points is on the interior? Okay, so what that means is that I need to take each one of these points and graph them and find which one is in the inside of that. So I'm going to go ahead and my coordinate planes have not been pretty today. Alrighty, so I'm going to go ahead and go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Hopefully this is enough. So negative 5, 3. So again, I'm going to go ahead and do negative 5 plus 2. So that's going to be a negative 3. And then we're going to do 3 minus 5, and so that's going to be negative 2. So that is my new point there. So negative 3, 1, 2, 3, down 2. So this is going to be A prime. Now let's do B here, and I'll move B over here. So negative 1, 1. So we're going to do plus 2 minus 5, because that's my transformation, plus 2, hence plus 2. Minus 5, minus 5. So I'm going to go ahead and get 1 and then negative 4. That's my B prime. So 1, negative 1, 2, 3, 4. B prime, and then C. That's negative 4, negative 2. So plus 2 and then minus 5 is going to give me negative 2, negative 7. So negative 2, negative 7 is going to be right down there. Alrighty, so we make a triangle here, and then we have to sort of speculate which one is going to be in that. So the only ones, remember that this is mostly in this quadrant, so I look at all these negative x's, which is great, but this is a negative 8. That's going to be way over here. We know that's got to be out. Then this is negative 1, 2. That's going to be right up here. No way. Negative 6, 5. Again, all the way up here. No apparent help. And negative 2, 6 is somewhere around right there. So we definitely want to pick A, even with my crappy graph. All right, time to move on forward to 26. So on 26, we thankfully only have one point that we're going to move, but it would be helpful once again to have a coordinate plane. So I got a problem with this example, and we'll get to it in just a second, but negative 3, negative 3. So that's going to be right here at A. So it says we're going to go and rotate around the point negative 4, 1. So negative 4, 1. 1, 2, 3, 4, 1. Is this going to be my point P? So what I do now is I know that this was originally negative 3, 3, but this is going to be basically, I'm going to pretend that this is my new origin. So I'm going to go ahead and make this my new origin. So a lot easier to see on graph paper, but this is over 1, down 1, 2, 3, 4. So this is now the point 1, negative 4. So now you're going to go ahead and do your counterclockwise rotation, which means it's going to go into this equation, or this, it's going to rotate that way, I should say. And so the idea is we're going to go ahead and make it 4, 1, but you're still going from here. So I'm going to go over 1, 2, 3, 4, up 1. That is going to be your A prime. So the original answer, though, to this as we reflected it would be, it looks to be 0, 2. Okay, so that is our point. So let's go through the progression here. I'm going to try to take away as much of this stuff as I can. So for our first part, A and A prime. So the distance between the point that I rotated it around is going to be equidistant in both of those. So those have to be the same because it's a rugged transformation. So that is true. So if this is true that they're congruent, one can't be twice as big. So the slope of this line, if we take a look at from A to P, here I have it in green, is I'm going up 1 over 1, 2, 3, 4. So this is 1 up, this is over 4. So H and F are both good. So then the slope of AP can't be 4 if it's going to be 1/4, so that's out. And it says that are these perpendicular? Well, this has got a slope of 1/4. This has got a slope of -4 over 1. Those are opposite reciprocals. So that's good too. So according to our answer key, that's it. And I double check this. Let me double check this for literally number 28. Again, doesn't have that right answer. So we're going to go ahead and, 26, not 28, 26. So it says F, H, and K. So we got those. But J is actually correct. And it's a fundamental thing for algebra is that any 2 points, there is one line. So it's not saying so I can make a line between those. So I would add J there. So I disagree with what's going on with our answer key. I would add J, but that's why I said I didn't really like that problem. All right, let's move on to 27 here. On 27, it's saying what quadrant will it move into? Okay, so this is where you get to sort of, as I mentioned a couple examples ago, sort of just eyeball it. So if we look at, for the majority of these, they are in this first quadrant, which is 1, 2. So 1, 2, which is going to be right there, 1, 4 right there, and then 3, 3 right there. I'm going to rotate it around this point, -2, 2, which is over here. And it's 270 degrees clockwise. So if this right here is my coordinate plane, I'm going to go, that's 90 degrees into one quadrant. That's 90 degrees into the second quadrant. And then another 90 degrees, or 270, because it goes 90, another 90 is 180, another 90 is 270. I'm clearly in this quadrant right here, quadrant 2. Alrighty. So, ladies and gents, this is one where it's saying what is A prime after the rotation. So the good news is I'm only looking at A here. So it's around the point -2, -3. So I go -2, -3. That's the point that I'm going to rotate this around. So I like to make this a new origin here. So this point is now 1, 2, 3, 1. So -3, -1. Alrighty. So we're going to rotate this around this point P 90 degrees counterclockwise, which is basically going to go that way. So I'm going to end up in this quadrant. So that means I'm going to switch their places. So it's going to be 1, 3. And then if I'm in this quadrant, though, according to my new one here, you're down here, that quadrant, your Y is negative. So I'm going to make that 1, -3. So over 1, down 1, 2, 3. So this is going to be our actual A prime. And so what is that according to our original, in the true origin here? That's down 1 over 1, 2, 3, 4, 5, 6. So that's why it's -1, -6. Alrighty. So in this next one here, sports fans, we actually have a double rotation. So it's best to do them in order. And then look at this really quickly. All these G's are different. So make your life easier by just doing G and find out which one of them is true. So if I look at G money right here, G is going to be the point -2 and then -3. So the first thing I'm going to go is a 90 degree rotation around the origin. So for the first time, we're actually going around the origin, so that actually makes our life easier. So when we are in this quadrant to go 90 degrees clockwise, we're going to go up into here. So I switch my X and Y to make it 3, 2, and then I say my X has to be negative because of the quadrant I'm in. So this is G prime after one movement. So let me go ahead and put that up. So -3, 2, so there's G prime. And now I'm going to do my translation here to do G double prime. So we're going to add 3 to our X, add 2 to our Y, and we're going to be at 0, 4. So 0, 4 is going to be G double prime. I erased the prime right there because it goes one move is G prime and then double prime is after 2 moves, and the only one that works for is B. So you're done. Yes, H and K will land where they're supposed to, but be smarter. So let's move to our next one here. And this next one, I'm going to need a quadrant plane. So I have 1 point. That point is -2, -5. So there's my point P. I'm going to rotate it counterclockwise, which means I'm going to go this way. So P at -2, -5. I'm going to switch it to become P 5, 2. And then in this quadrant number 4, your Y is negative and your X is positive. So this is going to be 5, 2. So 1, 2, 3, 4, 5, 2. Then I'm going to draw a line to reflect it at X equals 3, which is straight up and down. And so what you're going to do is you're just going to count 2 spots to get to that line and then go another 2 spots. So 1, 2. So that's going to give you the point 1, -2, which is going to be A for our answer. Alrighty. So I love these ones where it says what it gets you into the third quadrant, because it says basically just understand what the shift is. You don't have to do the actual math there. So first it says, let's go through, just start it, the first one. So Y equals X is that one right there. So if we reflect it around it, it's just going to flip-flop. And then, so it's not going to change because you're already on the axis. So I'm basically going to stay in this one. And then when I reflect it over the y-axis, I'm going to go over here. That's not quadrant 3, which is down here. So we know, sorry, you're out. So clockwise rotation 180 degrees. So that's going to end us right, yay, we're right here. But then when we flip-flop over the y-axis, we're going to go ahead and go, sorry, I did the wrong axis. I'm going to go back over here. Still not correct. Sorry. So this is going to go ahead and say, all right, translate it left 5. So I'm now over in this quadrant. And when it's just y, that means there's no up or down. And then it says rotate it 90 degrees counterclockwise around the origin. So then I'm going to land down here in quadrant 3, which is what I want. So we didn't actually have to do any math. We just had to know what was going on. So ladies and gents, that was 31. Making much faster progress on this video than the previous ones. Alrighty, on 32 here, it's saying which of the following is going to give us A to A prime. So you can go ahead and pick your A or your B or your C. Pick one point and get it there. So let's start with this first one. So it's rotated 180 degrees. So this is going to be the point 2, then 1, 2, 3, -2, 3. So 180 degrees would be 2, negative 3. So there's A prime right there. And then I'm going to move it up 8. Didn't work. Oh, I moved the wrong one too. So still didn't get us there. So let's try to move the right one here this time, which is A. And that's going to be at 2, negative 3. So you're going to rotate it 90 degrees clockwise around point C. So if it's 90 degrees clockwise around point C, that means it's going to go over here. I'm going way far away from that, what I want. So don't even try that one. So then we're going to do the same thing. It says rotate it around point C. So if I go 90 degrees counterclockwise, that's that way. And then it says 90 degrees clockwise about the origin. Then we're going to start, I should say A will be all the way over here. When I rotate it 90 degrees clockwise, I'm going to be back over in this section because it's around the origin. That's not it either. So last but not least here, my friends. So reflected over the line, y equals x. Sorry, y equals negative x, which is going to be this line right here. So if I go ahead and see that, we're going to flip it over here. So it's going to be 3, 2. And then we're going to move it over to the, there we go. Then we're going to rotate it to its position that it needs to be, which is D. Alrighty, so ladies and gentlemen, 33, I think we're done with our transformations for a while now. We're in triangle land. So it says we're trying to prove that these two add to 4. So what part should be in our proof? Well, think about this. The proofs need to always be true. Are there triangles where 1 and 2 are not the same? Absolutely. How about 1 and 3? These triangles, both are saying that this only works in isosceles triangles, which is not the case. It works all the time. So 1 and 3. How do we know 1 and 3 add up to 180? Because you don't. The only one that you know for sure is that 3 and 4 are a linear pair, and so they add up to 180. That's the only one that could possibly work. Alrighty, ladies and gentlemen, boys and girls, I apologize. I had to back up there. I made some errors, and so I just want to make sure that I fix those and I don't confuse anybody more than we already have. Okay, so let's go ahead, and we're trying to prove that there's 180 degrees in a triangle. So all the stuff that they've done up until this point makes sense. So what they're trying to do is they're saying, alrighty, we need to prove that there's 180 degrees. So those are 180 degrees, right? So we're going to say that the measure of angle 2 plus the measure of angle 4 plus the measure of angle 5 is equal to 180 degrees. And they set that up because they said that PCB was the same as those two angles right there, so we can plug them back in. Then we're going to go ahead and say, alrighty, we have two lines. This is our transversal. So that's an alternate interior angle, and that's an alternate interior angle. So angle 1 is congruent to angle 4. And then if we look at this, notice that they're combining steps here, which I'm not a huge fan of, but it happens. So then we'll do the same part over here. We'll draw in our parallel lines in our transversal so we can see our other alternate interior angle here. So 3 and 4, so angle 3 and 5. So if we say that those are the same, then I can substitute in this one for that one, and this one for that one. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. Oh, I skipped a step because it's the definition of congruence, so I have to say the measure of angle 1 is equal to the measure of angle 4. The measure of angle 3 is equal to the measure of angle 5. And then plug them in. So 1, 2, 3. 180. And so all those reasons, again, are B. All righty, ladies and gentlemen, boys and girls, 35. Back to an algebra proof. So it says, what is angle 2? So I'm going to go ahead and put an X there because that's what I'm looking for. So ladies and gentlemen, boys and girls, a couple of things you got to remember is that every triangle has got 180 degrees. So we're going to start with this triangle right here. And I'm going to call this Y just because I've already used X. So Y plus 21 plus 48 is equal to 180. And so to skip some steps here, Y is going to be 111. So now that I know that this is 111, I'm going to say, okay, this right here is a straight line. So we have a linear pair. So we'll call this Z. So the measure, we'll just call it Z. Z plus 111 is equal to 180. So Z is going to be 69 degrees. Cool. So if this is 69 degrees, like we said, every triangle has got 180 degrees in it. So that includes this one. We'll call this W. So W plus 56 plus 69 is equal to 180 degrees. So when I do my math here, I believe I get 55. Alrighty. And so if this right here is 55, we could then say, alrighty, this is a linear pair. So X plus 55 is equal to 180. So X is equal to 125, which is our answer. So just a lot of triangles. Now there's a bunch of different ways to do this one, but I'm a fan of 180 degrees in a triangle. And since there are so many triangles, they're trying to tell you to do that. So if this were a bubble in, we would go either 125 here or 125 there and call it good. Alrighty, so which of the following is always true? Okay, I always like these. So remember, true is that there's no or never, ever a counterexample. So on this one here, ladies and gents, are all triangles congruent? We know that that's because there's isosceles, there's right, there's scalene, equilateral, there's no way. Congruent figures have 3 sides. Well, do we have congruent angles? Do you think we could have congruent parallelograms? Absolutely. So it doesn't just have to have 3 sides. Alrighty. So if 2 triangles are congruent, then there must be right triangles. We just went over that. Boom. So our answer is C. If 2 figures are congruent, then there must be a rigid transformations that gets us or maps us one onto the other. So if this is one rectangle and this is another rectangle, and I say that they're congruent, I should be able to spin and move every point. That's what a rigid transformation means. Every point to match up over here. Cool? So that's why that one is C. Alrighty. So, ladies and gentlemen, how are we going to get this by SAS? Okay, they're trying to just basically use the SAS to try to trick you. This is a transformation question. How do I get this angle to be this angle, and that this side goes to this side, and this side over here goes to this side over here? Okay, so if I just rotate this right here, that seems like it would work, especially if I rotated it that way. Let me change my color here. But do you see how over here, this is kind of on the right, and then this switched over to the left? So that means a rotation is not going to do that, okay? Because this would still be on the right. So a translation would just move it up, left, down, and right, okay? So how are you going to, again, that doesn't deal with our flipping. So that's why we needed 2. So a translation, then a reflection, or is it going to be a rotation and a reflection? So again, when you translate, that when you end, it still looks the exact same way. Okay, so that's not going to work out for us when we do a translation. So it has to be a rotation. So we're going to rotate it around this point, and then we're going to reflect it so that this point now moves over to where it is. All right, which one of these is true? So that means we're just going to go ahead. I would say draw a picture is the easiest way. You don't have to, but A, B, C, D, E, and F. So A goes to D. So these two are the same. So all these have A goes to D except for these two. Then C goes to F, which is this one does not have C going to F, because notice what comes last, the order matters. So C to F. So we already know it's A. And then BC, BC is the last two letters, has to go the last two letters here. So BC right here and EF here. Alrighty. 39. So on 39 here, we're going to use this as our key to really help us out, because it looks like we can make a lot of assumptions here, and then we're going to get it all confuzzled. So the first thing I'm going to go ahead and say, we are trying to find Y. So Y is down here at P. So P matches to O. So that right there. So I get 5x plus 12 is equal to 5y plus 2. Well, I don't want to do an equation with x's and y's. That sounds like it's going to be trouble. So let's go and try to do just x's. So let's look at MP. MP, which is these last two letters, is going to match up to the last two letters over there, which is O and N. So we'll say, all right, x plus 4 is equal to 3x minus 12. So we're going to get x, 2x when I bring this over, and 16. So x is going to be 8. Look, they have an 8 right there to just distract us. So now we're going to put our 8 in over here. So 5 times 8 plus 12 is equal to 5y plus 2. So 40 plus 12 is going to give me 52. Is equal to 5y plus 2. 5y is equal to 50. So y is going to be 10. Cool. Alrighty, and just like that, we are to number 40, which is our last one of this video. And it's saying, what theorem can be used to prove that these are congruent? Okay, so I'm going to use, look, I got a 90-degree box right there. So the first one I'm thinking is HL. Let's see if we have a hypotenuse, which would need to be right here, RS, and OL, which they have right there. So that's check. We have the H. Now I need the leg. So the leg, I have two different options here. So I have LM. So LM is this one right here. And notice that this is the shorter one. So it needs to go the shorter one, which it does, MS over here. So thankfully we have our 2. So we'll call it HL. Alrighty, ladies and gentlemen, boys and girls, that does it for this video. You all take care, and we'll see you on the flip side.